All right, here's some great log questions. This first one's a nice one. They say they give you some framework for log base 2 of a, or log base a of 2 and log base a of 3. They give you some numbers for those. And then they say find the log base a of 9 over 8. Well, let's use a couple of the log rules to maybe break this apart. What I'm looking for are base 2 and base 3. So not base, but I'm looking for numbers that multiply to 2, multiply with 3, or that have 2 and 3 as factors. So first I'm going to use the quotient law. So the quotient law says if you have a quotient, then take the log of the numerator, take the log of the denominator, and subtract them. It's 1. I'm getting closer. And then let's take 9, and I think 9 is the same as 3 squared. Following suit with 8, I think 8 is 2 cubed. Notice I'm looking for a 2 and a 3, which I have right there and there. Okay, now I'm going to use the power rule to bring the 2 out front. So 2 times log base a of 3 minus 3 times log base a of 2. But up top here, log base a of 3 is actually equal to that number. So I can replace anywhere I see that with 0.4771. Minus 3 times log base a of 2 is this one over there, 0.3010. Now all I have to do is multiply this through, so that's 29542 minus, multiply this one, what would that be? 0309. I think that's right. Yep. And then subtract them. So 9542 minus 9030, 2150. So that would be my answer right there. Okay, all right, let's look at this one. Says use exponential to solve this. Now it's sort of hard to see here, but really this question is 3 to the x squared plus 3x is equal to 1/9. Again, I see 9, and I think in my head 9 is the same thing as 1 over 3 squared. Where I'm heading is I want 3 to the something is equal to 3 to the something. Okay, now if I have a positive exponent on the bottom, I can bring that to the top, and I make that a negative exponent. Okay, now if the bases are the same, I can equate the exponents. So I basically can drop the bases because they're the same. So it'll be x squared plus 3x is equal to a negative 2. Let me give some more room here. It's a quadratic, so I'll bring the 2 from here. I'll add 2 to both sides. And so this would be plus 2 is equal to 0. Then I'll factor. And factoring, I think I get a plus 2 and a plus 1. Therefore, when I use the 0 property, I get x is equal to a negative 2 or x is equal to a negative 1. Since this is an exponential equation, I'm fairly confident that both of those answers will work. Not a bad idea, though, to check. Let's just check one of them. Negative 2 I got, so x to the negative 2 squared plus 3 times a negative 2. Is that equal to 1/9? So negative 2 squared is 4. 3 times negative 2 is a negative 6. Is that equal to 1/9? Why did I put an x there? Should be a 3. Sorry. Should be a 3. I guess I have an eraser. 3. And then 4 take away 6 is a negative 2. Is that equal to 1/9? I'm pretty confident because that's 1 over 3 to the positive 2. You see where that's going. It does check out. Good idea to check the other one too. It's always good to check those. All right, here's another question. So it's a logarithmic equation, and this one I'm going to have to squish the logs, change form, solve. So it's a plus here, so I can squish these two and just write under one big logarithm, and it'll be the product of x plus 5 and x minus 5, okay, is equal to 1. So I've squished them. Now that I just have one log on the left side, now I can change the form of this from log form to exponential form. Here's my base. So 2 to the first, that's that, is equal to the stuff I was taking the log of. No more logs. Okay, and now let's FOIL this out. So this would be x squared minus 5x plus 5x minus 25. These cancel. So it'll be x squared minus 25. Since there's just an x squared here, I'm going to add 25 to both sides. There's no x term, so I can solve this using the square root principle. So this will be 27. I'm just going to carry on over here. So I've got 27 is equal to x squared, and I'll take the square root of both sides. Square root, square root. So this will be the square root of 27 is equal to x. Oh, I forgot, when I use this principle, I've got to make sure I put a plus or minus there. Now 27, I think I can simplify. It's the same as 9 times 3. And it'll be the square root of 9 times the square root of 3. And the square root of 9 is 3. Plus or minus. So my answer is plus or minus 3 root 3. Now, if I take the negative of that and plug it right in there, log base 2, it'll be, the answer would be like negative 5 point something. It'll be negative 5 point something minus 5. That gives me a negative 10, and you can't take the logarithm of a negative number, so I would cancel out the negative sign. So I'd say my only answer is a positive 3 root 3. Last question is a good one, a transformation question. Shape of y equals x squared, but upside down and vertically stretched by a factor of 8. So those are two transformations it has to, and I have to write the equation for that. If it's upside down, I know I need to put a negative somewhere. And if it flips over the x-axis, that's the A. So A, it flips over the x-axis, and it also stretches things and squishes things. B, it flips over the y-axis, and it squishes and stretches things horizontally. C moves things left to right, D moves things up and down. But they say they're flipping it upside down, so that means my A here has to be negative. Then they say they vertically stretch the thing by a factor of 8, so that's also my A, that's my stretchy guy. And so to write my equation, this is the general one. To get it flipped upside down, I need to put a minus in front. To stretch it by a factor of 8, I put an 8 out front. Done. All right, hopefully that helped you with those questions.